In this video, let us see the classification of magnetic materials. Materials can be classified into three categories: diamagnetic, paramagnetic, ferromagnetic. Examples for paramagnetic materials: bismuth, copper, water. Paramagnetic material, example, aluminium, platinum, chromium. Ferromagnetic materials, example, iron, cobalt, nickel. Let us see now its properties. For diamagnetic materials, susceptibility is a negative quantity. Relative permeability is lesser than 1. Then susceptibility is independent of temperature. When temperature is changing, susceptibility will not change. So that's the meaning of independent of temperature. Then if diamagnetic materials are kept in an external magnetic field lines are repelled or expelled. Then properties of paramagnetic materials. Susceptibility is positive, but a small quantity. So paramagnetic materials can be magnetized. Relative permeability is greater than 1. Here, susceptibility is inversely proportional to the temperature. That means temperature increases, susceptibility decreases. Here it is independent of temperature. Then magnetic field lines are repelled in the case of diamagnetic materials. But when paramagnetic materials are kept in an external magnetic field lines are attracted. Then ferromagnetic materials, susceptibility is positive and very large. You know, iron can be easily magnetized. So susceptibility is large. Susceptibility is a measure which tells us whether it is easy to magnetize or not. Here, susceptibility is very large. Relative permeability is also very large. Susceptibility is independent of temperature. Then magnetic field lines are strongly attracted when kept in an external when ferromagnetic materials are kept in an external magnetic field. Here you can see as the temperature increases, susceptibility decreases. So there is a law known as Curie's law that let us see next. Now let us see the reason for the differences in the behavior. You know that substances are made up of atoms. Electrons are in various orbits. Because of this orbital motion of the electrons, there will be a magnetic field. So there will be magnetic moment because of this orbital motion. In the case of diamagnetic materials, net magnetic moment of the atom is 0 because this plane of the orbits are oriented at random. Then because of this orientation at random, net magnetic moment of the atom is 0 in the case of diamagnetic materials. But when it is kept in an external magnetic field, some of the electrons are speeded up and some of the electrons are slowed down. The electrons whose magnetic moments are anti-parallel to the external field will be speeded up. So it will acquire a magnetic moment opposite to the external field in the case of diamagnetic materials. But in the case of paramagnetic materials, the atoms, there will be magnetic moment. In this case, for atoms, there are no magnetic moments. But in this case, atoms, there are magnetic moments. But when there is no external magnetic field, net magnetic moment will be 0 because magnetic moments of each atoms are oriented at random. So net magnetic moment of the material is 0. But when it is kept in an external magnetic field, it will be aligned in the direction of the external magnetic field. The magnetic moments of each atoms will be aligned in the direction of the external magnetic field. But in the case of ferromagnetic materials, there will be domains. In each domain, we can see magnetic moments are aligned in a particular direction. But when it is kept in an external magnetic field, you can see that all are aligned in the direction of the external magnetic field. There's a difference between these paramagnetic and ferromagnetic. Here there are domains. Then when it is kept in an external magnetic field, all the magnetic moments are aligned in this direction of the external magnetic field. Now, Curie's law. Susceptibility is inversely proportional to the temperature, where the C is the constant, Curie's constant. See the graph, susceptibility, temperature. Temperature is marked along the x-axis. As the temperature increases, susceptibility is going on decreasing. This is known as Curie's law, and C is called Curie's constant. Then Curie Virus Law. So you have seen that as the temperature increases, susceptibility decreases. Because of the thermal vibration, this alignment will be upset. So as the temperature increases, susceptibility decreases. Then as the temperature increases, susceptibility will be going on decreasing. At one particular temperature, ferromagnetic materials will become paramagnetic material. That particular temperature is known as Curie temperature. Now, Curie Virus Law, susceptibility is equal to C divided by T minus Tc. This Tc is the Curie's temperature. Curie's temperature is the temperature at which ferromagnetic material will become paramagnetic material. So this is the Curie temperature. Above Curie temperature, this is the relation. As the temperature increases, susceptibility is going on decreasing. This relation is Curie Virus Law. Thank you for watching.